Hello, my name is Kurt Jones. I work for Colorado State University Extension, and I'm a graduate student in the School of Education at Colorado State University. Today I've been asked to talk to you about levels of measurement as it relates to quantitative data analysis. So sit back, and I hope you enjoy the show.
I'm going to begin exploring levels of measurement from a traditional standpoint to begin with. The most basic level of measurement would be called nominal. Nominal is two or more unordered categories where the researcher assigns numerals, but there is no implied order or value associated with those categories. Therefore, you cannot treat the numbers identifying those categories as numerical digits used in formulas, so you can't add or subtract, that type of thing. So for example, if we were looking at a study where we were identifying graduate students in the School of Education as a quantitative researcher, a qualitative researcher, or a mixed methods researcher, we might assign numbers of 1, 2, and 3 for those nominal categories. Because we can't use those as numerical digits, two quantitative researchers do not equal one qualitative researcher, and a quantitative and qualitative researcher working together do not a mixed methods researcher make. The next level is called ordinal. These are ordered levels in which the differences between are not equal. Ordinal scales are also not normally distributed. So for example, the difference between the baseball teams in the National League West as of June 11th, 2012 shows the Los Angeles Dodgers leading that division. San Francisco is 5 games behind them. Arizona is 8.5 games back. Colorado is unfortunately 14 games back, and San Diego rounds out with being 19 games back. As you can see, the differences between first and second are different than the difference between second and third, which is different between third and fourth, and so on. The highest levels of measurement in a traditional standpoint are interval and ratio. Interval measurements are ordered levels with the differences being equal, but there is no true zero. And an example of this might be psychological tests. If you were taking a Myers-Briggs type indicator, you probably did not score 0 for introvert or extrovert traits. There's probably some components of each of those in everyone. Ratio, however, is ordered levels with the difference being equal and exhibiting a true zero. An example of this would be physical traits. You could conceivably have a trait where the weight for an object is 0. Height starts at 0, those types of things. The good news for this is that for statistical analysis purposes, they can each be treated the same, so this distinction between ratio and interval is not important as long as they are normally distributed. Looking at how SPSS deals with levels of measurement, the nominal and ordinal are the same as the traditional terms. However, SPSS incorporates both the interval and ratio levels into one category that they call scale. It is important that you label the variables into one of these 3 categories in the measures column correctly. It's important that these variables be correctly labeled to choose and interpret appropriate statistics. Finally, Morgan et al. Defined their levels of measurement a bit differently. Nominal they consider to be 3 or more levels, not ordered, and can be placed into true categories. This is similar to traditional nominal, but excludes the binary or 2-level. Dichotomous is a nominal level with 2 levels, ordered or not. An example would be gender, male or female. If we were looking at whether a participant in the study is a student or a teacher, that would be another dichotomous order. Ordinal are ordered levels, unequal between levels, and or the frequency distribution is not normal. I talked about the standings in the National League West. This would be still considered an ordinal scale. Finally, they round out their levels of measurement by talking about normal or approximately normal. This is equated with the interval ratio in a traditional term or scale terms previously discussed. Many ordered levels are scores. An example would be a Likert scale variable.
Well, there you have it. Hope you've enjoyed this introduction to quantitative data analysis and levels of measurement. This has been Kurt Jones broadcasting to you from an undisclosed central Colorado trout stream. So if you'll excuse me, I think the fish are biting.